All right, let's get started. So for today, I want to continue talking about leaf map. So in the last lecture, we have covered some of the basics: how to create maps, how to visualize all kind of vector data, raster data. And so for today, I want to cover a little bit more about some of the more recent vector data format, the so-called cloud native geospatial data or cloud optimized. And it's going to become more and more popular in the future. So you certainly need to know some of these data formats. Okay, in the future, it's going to be in the so-called geospatial big data. You're going to encounter this kind of format um, more often in the future. So if you the only data format that you know is H3 file, it's not going to be good. Okay, so you need to know a little bit more after you have taken this course. Um, H3 file or GeoJSON are very common, but those datasets are not suitable for large dataset. Okay, you can certainly use database, but database is also a little bit more challenging for most users to handle because you need desktop GIS to do that. But nowadays with cloud computing and a lot of like so-called cloud native format, you can actually access a lot of these large data set in the cloud using just web browser, and you can retrieve the data um, using some of the packages that designed to handle some of these data set. So um, there's a website that I would like to show you. I think it's called Cloud Native Geo. Um, Cloud Native Geo Guide or something. Okay, Cloud Optimized Geospatial Format Guide. And this is the one I would recommend if you really want to learn the latest one about some of the geospatial data format being used in the industry, then this is probably something you want to be familiar. And so the last lecture we already covered GeoParquet. Okay, so this is one of the data format for storing vector data in the cloud so that we can retrieve the data by column. It's very, very efficient. And there are a couple more, for example, flat GeoBuff. So this is another popular geospatial data format, and also the PMTiles. And later I'm going to show you how we can utilize the PMTiles to basically visualize geospatial data, large geospatial data set. And you don't need a server, you don't need anything, you can just put the data in the cloud. So I'm going to show you some examples. Let me hide the taskbar. So let me go back to the notebook here, the leaf map. And so I'm going to show you some of these examples here. We're going to look at the PMTiles. If you have never heard about this, PMTiles basically is just a vector data format for storing geospatial data. It can be vector data, raster data, but the most popular one is for a popular application is for storing vector data. And if you click the website, it will take you to somewhere here. So it's basically just a portable archive of vector data. So similar to some of the data format that we have been using, for example, XYZ tile layer or WMS. But the problem of those is that you need to have some kind of server to actually handle the rendering or the handling the request for people trying to access your website. So you need to maintain a server. But PM types, you don't really need a server. The PM type basically is just a single file that you can put on the internet anywhere as long as accessible through HTTP. Then you can just have applications pointing to the file. Then you can access that. So you can think about it just like a file you dump somewhere in the cloud. You don't need a server, so you can put it somewhere on even for example GitHub. It will be just able to actually retrieve the data, and the file itself, this PM tile, just a single file, it can be couple hundred gigabyte. It can be tens and tens of gigabyte. It doesn't matter. So it's a very nice format that allow us to access a large amount of data on demand. So that means, for example, you can access this data set here. So this one is, for example, built on top of OpenStreetMap. So you can have all the OpenStreetMap data as a single file put somewhere, and then allow the user to actually access. The nice thing about this is that the PMTiles allows you to customize what the data are going to look like. So it's not just like everyone's using the same color. You can specify what color do you want to see, what symbology you want to use for your vector data set, and then you can make your program utilize some of those styles so that you will render to whatever way you want. So, for example, this is just a single PMTiles, and like I said, it's accessible through HTTP URL. If you click any PMTiles URL, it supports a dialog. If you click, for example, this one, if I click here, it supports and asks you to actually to download this one to your computer. Okay, if it doesn't, that means the URL is not right. So it needs to be the so-called direct URL, and this may have some of the functions allow you to look into the metadata. For example, you can call this function, and then you can show you what kind of data layer inside. So the PMTiles can have multiple data layers. Unlike GeoJSON or shape file, there's only one data layer. There's either polygon, line, or point, right? You cannot have multiple geometry type in the same file. Okay, but for PMTiles, you can have multiple. You can have a lot of data layers inside, and you can also figure out what's the bounding boxes. So this can be useful if you're trying to visualize the data. So you can zoom to the bounding box of the data set. Now with this, let's take a look at this. I'm just going to basically visualize this one so you can take a look what it looks like. So for this one, we have in the simple, for example, OpenStreetMap, and then we have this data layer here in blue color, and we also have the black outline. So look at this. This is just a simple PMTiles, and you can specify the data layer. So the way that you know what data layer you want to render is from here, right? So for this data set, we have a bunch of data layers in here, and we can just render it by specifying, for example, the ID, the source basically come from this source. Okay, so the URL is the one we specify. So you just need to follow the same structure. And so inside here, we're going to use maybe the source layer, the land use, and also the rows. So the land use, do you see if there's a land use somewhere here? Oh, where is it? Oh, the rows and land use. Rows here, right? And where's the land use? Rows and buildings. Oh, sorry, the ID. It's the ID column. The ID column. So the source layer is the name of the layer you want to specify. So the source, basically this is the data source, basically the PMTiles data source. And then you specify what ID. So we're going to specify the buildings and also the rows we want to display here on the map. And then you can just call the leaf map add PMTiles function to render the data layer. It's kind of similar to the GeoJSON that we have developed. The difference is that this is using kind of like so-called map box or map library style. So it's a little bit different. We're using the so-called paint. So how you basically what you want the data layer to look like, and we change it. For example, the fill color to steel blue and the line color to black. You can certainly change it. So think about this is the data not hosting on local computer. The data is in the cloud. So we are just retrieving the data and then render it. If we want to change the color, for example, to green, what do you do? Can we do that? Very simple, just type green. It's very, very powerful. So you can actually customize the color to see what it looks like. And compared to XGeoJSON, you can also do that. You can have a GeoJSON file, host it somewhere, and then you can render it. But keep in mind, GeoJSON is not suitable for large data sets. So if your file is like 100 megabyte, this will take you forever to render. But for this one, you can render 100 gigabyte file, it doesn't matter. Because inside this file format, it has so-called pyramid, has multiple data layers. So when you are looking at the data, you only download a small piece. But for GeoJSON, It doesn't matter how big is the file, it's going to download the entire file. And it's going to be very slow. So this is just something that you need to pay attention. So next, I'm going to show you, for example, how about this one? Show you, okay? So this is another vector data set. It should not take a while. Well, okay. So you see, this one has the building footprint, the data layer, and also this is the bounding box. And I wanted to show you the differences. Look at this one. Again, I can click on this one and then try to download it. I don't know how big is the file, okay? Let's figure it out. My computer might be frozen, but let me just try it save. How big it is? Do you see it? $194 GB. Okay? This single file is 194 GB. It's going to take 23 hours to download. Okay, so we'll be waiting here and then come back tomorrow. It's not going to work. So, and the power of using this file format is that this is so-called a cloud native format. That means you don't need to download the file. You just render it. You will just download the file, a tiny section. So depending on your area, depending on your zoom level, inside it has all the pyramids. So that you only download the data, a small subset of the data. I hope it's not taking my space. Anyway, so now let me show you how do we render it. The same idea. So we're going to add a base map, and then we're going to style it. The source basically is the example source, is basically pointing to this PMTiles, and then we're just going to render the data layer. So the source layer, we are using the building footprint, because inside it has this building footprint layer, and then this is what we're going to color. Okay, so you can have to specify the color and also fill opacity. After that, we just use the PMTiles. So let's just see if it works. All right. So this 195 GB data, now we can just render it on, inside here. We can zoom in to see. Right now, it's not very clear, but if you see those blue color, it's going to show up like slowly, depends on the zoom level. So see this. So this data set is a global data set with almost 200 GB, and we can render it just without any problem. See here? Oh, will you prefer to wait 24 hours tomorrow, like come back tomorrow to see the data? No, right? So if you have any big data set, if it's like a couple hundred megabyte or gigabyte, you want to use this format because it allows you to put the data somewhere, and anyone can create web applications to actually to visualize the data. It's super powerful. So of course, if you zoom out, it's not going to show you. It's actually resample. So you don't actually see it's all the red blue color, because the data layer only show at a certain zoom level. So if you zoom in, it will show you more buildings, show you more details. It will just show you an overview. It doesn't sometimes even show up, right? It's really hard to see if there's any buildings in here. So this is the power of PMTiles. Basically, it has different zoom level. And for every zoom level, it has basically a copy of the data. So basically, it's just a small overview. And you can zoom to anywhere, it will just show up the data slowly. So this is a data format that you certainly want to pay attention. So it's very suitable for large data set. Very easy to use. All you need is just put it somewhere, generate the file, and then put it somewhere, and then you're good to go. If you want to, for example, generate some vector data to PMTiles, you can just call leaf map. So I think it's called vector to PMTiles. So it allows you to convert any vector data format, GeoJSON, swap file, or I think even maybe GeoDatabase. Any vector data format supported by GeoPandas, you can convert it to PMTiles and then just dump the PMTiles on GitHub or somewhere. Then in your web application, you can just pull the data, render the data in, directly if you want to. Make sense? So it's very, very powerful. You can try it. So similarly, I have the other one here. I'm going to use the Overture Maps data. So this is another type of a global building data set. And I can also render using this. Basically the same workflow. They come up. Do you see the yellow color here? So this is also the global building data set. And same thing. If you want, I can show you the URL. All right. So if I click this one, and you see it's pop up popping up a dialog asking to download the data set. And I'm not sure how big is this one. Okay, let me save this one to see how big it is. Click save. All right, how about this one? 136 gigabyte. A huge data set. Again, we don't want to download it. This file is just too big. So this is a better way of doing the visualization. So only just learn from this example. Of course, the data set is like not perfect. There's some like new residential area. The building has not been created yet, but this is freely available building data set for the entire globe. You can also render rows, the country boundaries. There are lots of data set available. So you probably need to, if you want to learn more detail, you can go to the website. So this is called Overture Maps Foundation. It's a big, new open access data initiative by Meta, Microsoft, Amazon, some of the big tech companies. So they create those data sets. You can take a look at the data available, where to download the data, and also how to visualize the data. They release the data every couple months. And it's super powerful. You can also go to this Overture Explorer to actually see the data. So they have tons of data. You want to maybe look at some of this. And you can also visualize the data in 3D if you want to. It might have building height, so it's actually pretty powerful. So you can look at some of this in here. And so the data set, they provide the so-called PMTiles. This is why you can actually access the data. For example, here, different algorithm and examples. PMTiles, how do you access the PMTiles? So they have the URL, they have the something like this. You need to basically look into the information how to access that, but it's all freely accessible, super nice. So if you want to download the data, you can, but most of the time you just want to do visualization, you don't need to download the data. So for example, we have this data set. Now we want to visualize that. I don't like the yellow color. I want to change it to something else. Okay. I just want the, for example, the outline. I don't want to fill the color of the building. Can we do that? Do you know how to do that? All right, fill color. You can just change the fill opacity just to maybe, or change the fill outline color. So this is the one you change the color, right? I can change it to red color. What's the hex code for red color? Oh, this one is already red color. Oh, I already used the red color. I think the problem is that right now with the fill color, this one is kind of like yellow. So you can change it to another color, or you can make this one a little bit transparent, for example. 1%. And then add this. Now it's even hard to see because it's too transparent. So the syntax is a little bit different than it's a little bit different than iPyLib, but reachable. So you can certainly just customize to whatever you want. So I'm changing maybe to 0.7. Can you make it more obvious? Okay. And this is at a global scale, so you can actually navigate to anywhere that you like. You will still be able to see all the buildings using the data set. They also have rows. They have other types of data. You can export those. So you can maybe utilize some of this for your final project. Okay, questions? So PMTiles is super a good data format for visualizing vector data, especially large vector data. Next, let's talk about raster data. So we have covered this one in some of the previous lectures. So you might already have heard about cloud optimized GeoTIFF. So it's just basically a GeoTIFF file similar to the regular GeoTIFF, except that it's called cloud optimized GeoTIFF because it's generating a bunch of pyramids inside the file so that you can retrieve the data on the fly. So you only download a small subset of the data rather than the entire file. It's the same. So the idea actually, the PMTiles actually brought the idea from the cloud optimized GeoTIFF. So cloud optimized GeoTIFF is for raster data. PMTiles is for vector data. But PMTiles can also store raster data as well, but it's just not as computing efficient as a cloud optimized GeoTIFF, but they are very much similar. So the idea is that you can host the data somewhere in the cloud, and you don't have to download the entire file. All I need is just like render the data. So Leaf map has this function called add COG layer, add cloud optimized GeoTIFF layer. It's kind of similar to the add raster function that we added to the package previously. But let's look at this file and try to render it, right? So we can create a map and then point it to the URL. Now we have this file. So if you zoom in, this is a very high resolution raster data set. It's sub-meter resolution. So you can see it's actually very, very clear. And the URL, it must be a direct URL. So if you click the link, it's open the dialog asking you to save the file. Okay, you want to guess how big is this file? How big? 2.9 gigabyte. Okay, so it's much smaller than the vector data, but it's still decent, right? And 2.9 gigabyte right now, it doesn't even show me how long it's going to take. It's going to take forever to download the file. But as you can see the example, it doesn't really matter. I can visualize the file nicely. So this is called data streaming. Similar to you are watching a movie on YouTube, right? Or it's what's a video on YouTube. The video can be like 4K. You can just watch it, and you're going to download all the data, but you don't have to worry about downloading the entire file because it's going to basically just grab the content that's needed when you're seeing that. You don't need to have the entire file. You just fast forward. You just like get some of the pieces from the data. So for the raster data set, I'm just rendering the data on the fly. Oops, looks like something is okay. So if you zoom in, it's going to basically load the data, and then slowly going to show it. Right now, probably my internet is a little bit slow, so it doesn't show it very quickly. But the idea is that when you zoom in, you have a higher resolution, but your area, because coverage becomes smaller. So still, you are only downloading a small piece of the data set. And let me try again. Oh, am I still downloading the data? Oh, I know why. I think the internet is down. Is it? No? What? Why it looks like it's not working? Oh, it's stopped working. So now the internet is not working. So that's why it's not showing up. Yeah, I'm using the UT open. Anyway, so let me not sure. Oh, okay, it's back now. That's good. Let me pull this one again. And visualize raster data layer. I execute this one. Yeah, because most of the data that example that they utilize is from the internet. So we do need the what okay, it's gone again. So not sure why, but without the internet, this example will not work. Okay, I cannot really show you anything. But if you work on your computer, you can try some of these functions. So AdCog layer will allow you to visualize any raster data layer stored in the cloud, as long as it is a cloud optimized GeoTIFF. You can do that. Okay, right now it's not working because of the internet is down. Oh, okay, it's back again, but it's not very stable. So try this one on a computer. Hopefully, you have better internet than my laptop. So echo layer is similar to add raster function that we created before. Difference is that echo layer is dedicated for raster dataset hosted in the cloud, hosted available through HTTP URL. The add raster function is designed for visualizing the file deck on your local computer. Make sense? So if data locally, also have data in the cloud, the add raster function is for data locally. You can certainly use it to also visualize data in the cloud, but it's not as efficient as this COG layer function. So you might want to try this one out and see how it compares to some data set hosted locally. You can also use the COG info to see some basic metadata about the file that you are accessing. Okay, finally, so it works again now. We zoom in. I think it's not super stable. Anyway, so if you run this COG info function, it will just show you some of the basic information. And it's going to show you the how many bands, the data types, overview. So this is the why it is called cloud optimized GeoTIFF. It is because it has so-called overviews. Overview means you have different zoom level, and if you have that, that means you have the post resolution version of your data set. So when you are visualizing the data, you are only downloading small subset of the data. And we also show you how many bands of the data set. And you can also calculate some simple statistics if you want to. So you might have multiple bands, right? So for each band, you're going to have the minimum, the maximum, standard deviation. You can also have the histogram, all kind of stuff. So this is something you want to inspect if you want to. And similarly, if you want, you can just use COG, image to COG. If you have any raster data set you want to convert to cloud optimized GeoTIFF, you can try this function. If you have a regular GeoTIFF and it's not a cloud optimized GeoTIFF, you want to convert to cloud optimized GeoTIFF so they can put that in the cloud and so they can stream the data using your package. Then you want to make sure that it's cloud optimized GeoTIFF. Otherwise, it's going to be very slow when you're trying to visualize the data from the cloud. Okay, and also you can visualize multiple cloud optimized GeoTIFF. For example, this is another cloud optimized GeoTIFF after the event, so before and after, and then you can actually visualize them together, right? So we have two high resolution satellite data here, and so in this area, it had a wildfire at the time. So this is basically after. See from here, this is the post event. This is the before event. And you can see the file actually somewhere here. You can overlay the two data layers together, or you can read a so-called split map. And this is the one that what we did for the midterm exam. Remember? But at the time, I asked you how to create this function. If you're using leaf map, it's just one line of code. Create a map and then just create a split map. So in this way, now I can have this to visualize any data from anywhere. It doesn't have to be these two data sets. It can be any data set. You'll be able to visualize that directly, right? So this is just a simple application showing you how to visualize data set before and after the event. So all you need to do is just to have the URL and then 1 and 2, right? So you have URL 1, URL 2, and then you're going to visualize. Also, by default, it's going to automatically zoom into the area of the data set, right? So I have these two data sets, but I can also maybe, I think at the bottom here, I have an example. Let's say I have these two URL, and I want to visualize the data set. It's super easy. So I can just simply copy this one and come back to here. All right, so inside, I can have just have this. Okay, but you need to define the URL, the function, the parameter, then the URL. Move this one, URL2 equal to double quotes, and that should be it. Okay, create a map pointing to the URL of these two files, and then just call this split map function. See if it works. We still have internet, so hopefully. Okay. And it automatically zoom to the area, right? So it doesn't matter where's your file. You're only going to figure out the bounding box and then zoom to the bounding box. So this is something you can think about in your package if you want to browse some of these functions into set. And now with this, I can quickly look at the data before and after. So if you're working on any project, you're trying to compare the data, for example, hurricanes before and after. If you have the data layer, you have the raster, you have the imagery, then you can just use the split map to actually compare the data side by side. Also, you can have this one, the label here, left on the left, low left, and also low right corner. So this would be this label. You can customize the label to whatever label that you want. And that's super efficient. You don't have to download the entire data set. So these two data sets can be a couple hundred megabytes or it can be gigabyte data. And you can just put the data somewhere. So if you acquire the data, you have downloaded the data from some data portals, and then you want to develop some applications that you want to showcase, and this is something you can do easily. Questions? So the next example is about comparing multiple geotiff on the same map. So we have it's basically two imagery, okay? The base map and also the building outline. So the building outline is just the raster data set of the buildings. And you can see they have different colors. The reason for that is the color is based on, I think, the unique ID of the building. So basically 1, 2, 3, 4, 5. If you can see they're next to each other, they kind of have similar color because the ID is similar. So you can have this, you can have two data layers together. Same idea, so it's just the URL. And again, you can just click the link. You can download the data to your computer if you want to. And this one is a pretty small file, so it should not take you too long to download. Okay, this one is only 8.9 megabyte. And the second one should be much smaller. Okay, it's only 57K. So those files are too small. But like I said, you can just put any data set in the cloud, and then you can just use the LeafMap or your own package to visualize the data. So the nice thing about this is, if you're developing notebook examples, you want to showcase the functionality of your package. You don't want to put those data in your GitHub repository because it will make your repository much bigger. And also, when you have those examples, you need to make sure that the user have access to the data. You need to download the data, and then you need to make sure that the data is accessible in the notebook so that user can run it. But this is a much better way because anyone can open, and then because the URL is accessible to everyone, so you can just use the same example. Just like right now, you're trying this one on a computer. Does it work for you? You don't have to change anything, right? You just walk out of the box. So this is something you think about when you develop some examples for your package. You need to make sure that your examples run smoothly on different platforms, different computers. It doesn't matter whether it's Linux or Mac or Windows, or it's using your web browser, Chrome or other browser. It doesn't matter. It will just work just fine because it's using the same protocol, using the HTTP URL. You can also customize the map, right? So by default, it was just using a grayscale color, but you can actually specify a color map. In this example, we are visualizing the national land cover database. So we're using this at COG layer and then the URL. So this is the data set that I put on my GitHub. Okay. So it's an NLCD national land cover database, 30-meter resolution. So this is a pretty decent size file. Again, let's try and see how big it is. Okay, I'm gonna download it. Okay, 1.5 gigabyte. It's not super big, but still big enough. Because if you're trying to download the data, it's gonna take a while. So using this same function, add COG layer, and then the URL, here you can specify the color map. So if you don't by default, if you don't specify the color map, it's gonna look like this. So let me remove this one just to show you the difference. If you don't specify the color map, it's just a gray scale, and it's not going to look super nice, right? So this is sometimes when you open some raster data set, in desktop GIS, the color is not, basically they don't have the lookup table for the color. So by default, it's going to render it something like this. And since this is the national link cover database, we already know for each value what kind of link cover type it is. And they also already established a color map. And this is why we want to specify the color map parameters. So the color map basically come from here. This is where we specify, okay? So for example, 11 is what? Open water, right? And you can also specify the color. So the color here is the hex color code. And this is something that you certainly want to pay attention. Is that allows you to render the imagery, especially if there's a single band. You can render it in a nice way using the color map, right? So this is exactly what it looks like. And if you want, you can just say, okay, NLCD legend. Okay, if you go online, it will show you the legend and also the different color of the for each type. So for example, this is basically the color table, right? 11, blah, blah, and then the color for different color, they have different, represent different lane cover type. So what we're doing here is we have this data set, but it doesn't know what color it looks like. So you're going to give each lane cover, each value, each lane cover type a different color using this so-called color map. So it's very, very flexible. You can change it to whatever you like. I can also change this one, for example. I want the open water to just like pure blue color. What's the hex code for blue color? FF, right? RGB, okay? Red, green, blue. So this is 16 hex color code. So F means 255. FF means 255, okay? And so if you run this one again, you should see the water being rendered as blue color, okay? So you can change whatever color you like, but you need to make it correspondent to this one here right now. This one is using a default legend, so it doesn't, the color doesn't match. So if you change this one, you also need to change the legend to make sure that you same color. But this is something very powerful, and you don't have to download the data. So this is so-called cloud optimized GeoTIFF. If you're interested in like working in the industry, these are some of the new data format you make sure you understand how to actually visualize or run computation or do all kind of things. So cloud optimized GeoTIFF is powerful, and PMTiles is for vector data, but this one is for raster data. If you have something locally, for example, I'm going to have a sample data set. Like for this data set, I can actually just use the ad hoc layer to render it directly. But you can also download the data to your computer. Then you can use this add raster function. Oops. Okay, I'm seeing I'm using this dependency. So let me install it quickly. Pip install X array. Right. Then let's try again here for leaf map. I'll download it and then render it. Okay. So we have this data that we downloaded from the internet. Now we are rendering this file on our local computer using this so-called add raster function. Right. So this is the function that we created for our package, but you can also do it like this. Okay. So for here, I can just m.add hoc layer, and then just pass in the URL. You can give a name if you want, but oops, or DM URL. Okay. So right, although it looks different because we haven't specified a color map yet, but I'm just showing you there are multiple ways you can visualize the data. If the data is in the cloud, you use the code layer. If the data is locally, you use the add raster data layer. And if you want, for example, to get the same color, I can use the color map. The name is a little bit different. because you use different backend. So if I'm using the cloud one, I need to use the parameter name called color map name rather than, oops, changed already. Maybe just color map. I forgot what it is. Oh, interesting. It should be color map name, and then maybe cool warm works. Okay, so maybe just the color map name is not available in the the so-called the T tiler. So echo layer utilize the T tiler backend. I don't want to confuse you, but the echo layer basically has a middleman somewhere. It's a server. So when you are rendering the tile from the server, you're actually passing to this server, and then you are rendering the tile from this server. It's oops. Or you need also need this one. Go to this one. Keep install Royal X-ray. Hmm? IST. What? Oh, right. So now so we should have this one now. Leaf map DMUIL. Then you can use the image minimum maximum to look at the value. You can also add a color map. So leaf map. Oops. Execute this one first, and then just add a color map. Add raster. Oh, you can also specify color if you want to like provide a custom color map. So the color map parameter allows you to specify the symbology. This is similar to visualizing a dataset using desktop.js. So when you open the data, then you can change the symbology. You can specify here blue, green, and white, right? So it means from the lower elevation to higher elevation. So high elevation is white color, low elevation is blue color. So if you want to add something else, I can add, for example, red. Okay, wait. Okay, here. Now you can customize to whatever way you want it to look like. So that's for a single band raster. For multi-band raster, you can also use the add raster function. The only thing that you need to specify is to have this so-called indices. So the indices means if the file has more spectral bands, you can specify what spectral band you want to visualize. So 4, 3, 2, 4 is the near infrared, red and green. But you can also visualize that one using just RGB, right? So here I can change it to 3, 2, 1, and see what it looks like. Where is it? Okay, so right now for this one, it's the natural color, red, green, and blue. And so if your data set has multi-spectral bands, you need to decide what you want to visualize. Otherwise, if you don't specify, it will just be the first band, right? So if I don't specify the indices, it will just visualize just a single. Oh, it only single is the first 3 bands. But you can also specify just one spectral band. I can just do 1, right? So if there's one spectral band, that means it's just a grayscale color image, right? So red, green, and blue. And so for each band, it's just like 0 to 255. This is why it looks like this. If I choose the index 4, what do you think the pattern will look like? It's still going to be a grayscale imagery, but you're going to see something very different. So the band 4, for example, 1, 2, 3, 4, right? Blue, green, red, and near infrared. So what the water will look like in a near infrared spectral band? Is it going to become brighter or it become darker? Have you taken any remote sensing courses? What would water look like in the near infrared band? Or what would water look like a vegetation, the spectral reflectance of a vegetation in near infrared band? Is it going to be high or low? Yeah, really dark. How about vegetation? High. So what you're going to see is right now, this is band 1, right? Just blue band. You can see the blue, the water still look a little bit bright. But if I change to band 4, then it's going to look very different. So the water going to be much darker, and then the vegetation going to look brighter. Make sense? So right now you see the water here, really dark, because in the near infrared band, water is being absorbed by the reflectance being absorbed by water, so it's not actually reflect. But for vegetation, it's the opposite. So that's why vegetation, right? You have both color composite, red, near infrared, red and green. So it all looks like red color. It's because the spectral reflectance in the near infrared band is very high compared to other spectral bands. Okay, so that's about the visualization. So last example to show you is this may also have some pixel inspector. So if you open this one, right, and you're trying to create some samples, creating some sample, trying to figure out what the value of each pixel, you can use this one. So if I click, okay, you can see the values 1, 2, 3, 4, right? If you look at the vegetation, all the B4, right, it's really high. But if you look at the water, B4 will be really low. Right? So B4 is the near infrared, so it's much smaller than the red band. That's why it's so dark in here. And you can also zoom out. It's just like a marker cluster. If you want, you can download this one to your computer. You can download this one as a CSV, and then I can open this one somewhere. See, so this will be just a simple CSV that you can. And so right now, if you look at this one, you know how this one is made? What's this? This widget. What's this widget? Button? This one? Toggle button? Checkbox? Input box? Text? Drop down list? Checkbox? Button? 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 Right? It's not that complicated. But the source code is a little bit complicated, but you can certainly see everything is actually made from the IPy widget. Okay, we are almost time. So for the last section, the spatial temporal asset catalog. This one we just leave it to you for exercise. We don't have any lab assignment for this part. So, but spatial temporal asset catalog is also a new term. It's basically widely used in the last couple of years. It's basically something allows you to search and discover the data. And actually now a lot of data from NASA, from Google, from Microsoft, they are all using this so-called spatial temporal data asset catalog. Basically, you index your data and then have this JSON file that allow the user to query the data programmatically. It's a little bit more complicated, but just for your information, you can try it out. You can follow examples. So that's all for this section about leaf map, and I posted lab 9, so you can work on lab 9. So it only has 5 exercises. If you have followed the instructions and also use the example that I show you in the leaf map notebook, you should be able to finish this one within maybe a couple minutes. It's not super complicated. So hopefully it won't take you too much time to complete this lab assignment. All right, so that's all for today, and I will see you on Friday.